In order to prove in coordinate geometry, we need to use formulas. So if I want to prove that FOUR is a rectangle, I first want to plot those 4 points. And I'm going to connect those 4 points with line segments. Now, in order to prove that this quadrilateral is a rectangle, I need to first come up with a game plan. Now, to make this quadrilateral a rectangle, there's 2 different ways I can do that. The first game plan I'm going to come up with is to look at sides and angles in a rectangle. To prove that this is a rectangle, the first thing that I need to be able to do is show that my opposite sides are parallel. Now, in order to show that my opposite sides are parallel, FO and RU, and FR and OU, I need to prove that I have equal slopes. I need to use the slope formula and show that these 4 lines, the 2 opposite pairs, have equal slopes. Now that I have all the sides parallel, I need to prove that this is a rectangle by showing that I have 4 right angles. Well, to show that I have 4 right angles, in coordinate geometry, I need to use formulas. So I need to show that my consecutive sides are perpendicular. If I show that my consecutive sides are perpendicular, then I have 4 right angles. So I need to prove that my slopes are opposite reciprocals. So step 1 proves that I have a parallelogram. Step 2 proves that I have 4 right angles. Now I need to make sure that I have a rectangle and not a square. The difference between a rectangle and a square is this. In a rectangle, my opposite sides are congruent, but my consecutive sides are not congruent. So how would I prove that my opposite sides are congruent and my consecutive sides are not congruent? Well, I need to find the length of all 4 sides. To find the length in coordinate geometry, I'm going to use the distance formula. Now, that's not the only game plan I can come up with. I can also prove that I have a rectangle by looking at the diagonals of my rectangle. Now, the 2 diagonals in this picture are UF and OR. So my second game plan I can come up with is looking at my diagonals. Now, the diagonals in a rectangle do something specific. The first thing that happens is the diagonals bisect each other. If the diagonals bisect each other, that means that their point of intersection is the midpoint of both diagonals. So what I really need to do is make sure that my midpoints of each diagonal are the same. Now, in a rectangle, the diagonals do bisect each other, but that doesn't guarantee that I have a rectangle. I also need to show that my diagonals are congruent to each other. If I can show that my diagonals are congruent to each other, I'm closer to proving that I have a rectangle. To prove that my diagonals are congruent to each other, I want to find their lengths. To find length in coordinate geometry, again, I'm going to use the distance formula. And lastly, to separate this rectangle from a square, I need to make sure that my diagonals are not perpendicular. Squares have all of these, or these two first qualities for their diagonals, but their diagonals are also perpendicular. To show that this is a rectangle and not a square, I need to prove that my diagonals are not perpendicular. And to do that, I need to work with my slopes. And in order to show that they're not perpendicular, I need to show that the slopes are not opposite reciprocal slopes. So I have two separate game plans to prove that I have a rectangle. I don't want to mix up these two game plans. If I'm going to go with sides and angles, I want to stick with sides and angles. If I'm going to go with diagonals, I want to stick with diagonals. For the purpose of this podcast, I'm going to pick the diagonals game plan. I could just as easily have picked the sides and angles game plan, but for this purpose, I'm going to pick the diagonals game plan. I'm also going to do this work fairly quickly. If you need to hit pause along the way, do that. Hit pause, catch up your work, and then continue the podcast. Step 1. To prove that my diagonals bisect each other, I want to prove that their midpoints are the same. So I need to first show that the midpoint of UF, midpoint formula, add my x's, divide by 2, add my y's, divide by 2, is at 0, 1. And the midpoint of my other diagonal, OR, add my x's, divide by 2, add my y's, divide by 2, has to be the same. And when I do that math, I get 0, 1. So my two midpoints are the same, which tells me that my diagonals bisect each other. If they both have the same midpoint, they have to intersect. They have to bisect each other. So I have step 1 done. Step 1 proves that I have a parallelogram. Let's get a little more specific. Let's make sure that my diagonals are congruent. To prove that my diagonals are congruent, I'm going to use the distance formula to find the distance, the length of UF, and the distance, the length of OR, my two diagonals. To do that, I subtract my x's and square that answer, subtract my y's, square that answer, and add those numbers together. Now as I simplify my math, if you notice, I end up with 196 plus 4 and 100 plus 100. When I take 196 plus 4, I get 200, and when I take 100 plus 100, I get 200. So essentially, I'm getting the same answer two different ways. I want to show that my two diagonals are congruent to each other by showing that their lengths are the same. The measure of UF is equal to the measure of OR, which tells me my diagonals are congruent. So I've taken care of step 2. Now I either have a rectangle or a square. To prove that I have a rectangle and not a square, I need to show that my diagonals are not perpendicular. To show that two lines are not perpendicular, I need to find their slopes. So that's my last step. I want to find the slope of UF and the slope of OR. To do that, I'm going to use the slope formula. Subtract the y's over subtract the x's. Notice that I simplified my answer, negative 1/7 and positive 1. Since my slopes are not opposite reciprocals, they're opposite, one's negative and one's positive, but they're not reciprocals. Slopes are not opposite reciprocals. So my diagonals are not perpendicular. I've done step 3. Now if I can show that all 3 of these things are true, I can guarantee that I have a rectangle.